Welcome to the Explainer. Have you ever wondered how your phone knows it's you just by looking at your face, or how a self-driving car can actually see the road ahead? Well, today we are pulling back the curtain on the absolutely revolutionary technology that makes all of that possible: deep learning.
I mean, seriously, how does a machine learn something as fundamentally human as a first word? The answer lies in this incredible field of tech that's actually inspired by the way our own brains are wired. Okay, let's dive into this.
All right, first things first. To really get a handle on deep learning, we kind of have to zoom out and look at the big picture. Let's map out this whole universe of intelligent technology so we can see exactly where deep learning fits in. So, at the very broadest level, we have artificial intelligence, or AI. You can think of this as the entire universe of creating smart applications. It's any tech that can do its own thing without a person telling it exactly what to do step by step. Now, inside that universe, there's this massive planet called machine learning. This is a part of AI where, instead of writing endless lines of code with rules, we just feed the machine a ton of data and let it figure out the patterns for itself. And finally, this brings us to our destination for today, the continent of deep learning. This is a super specialized part of machine learning that uses these complex, layered networks that are literally designed to mimic the human brain, which lets it learn from just enormous amounts of data.
So, just to lock that in, AI is the whole universe, machine learning is a big planet inside it, and deep learning is this very special continent on that planet, and it's where some of the most advanced stuff we're seeing today is coming from.
So here's a fun fact. The ideas behind deep learning are not new at all. They actually go all the way back to 1958. So you might be wondering, why is it suddenly exploding right now? Well, it turns out there were two key ingredients that were missing until pretty recently.
The first ingredient was data. And not just a little data, a colossal explosion of it. Think about it. The rise of social media, Facebook, Twitter, Instagram, created this absolute flood of images, text, and user information, the likes of which the world had never seen before.
And companies, well, they quickly realized this data was a gold mine. Deep learning models, you see, are incredibly data hungry. They need tons of it to learn. And for the very first time in history, we had enough data to finally feed the beast, so to speak.
The second critical piece of the puzzle was hardware. I mean, all that data is pretty useless if you don't have the horsepower to process it. We finally developed the raw computing power we needed, and funnily enough, it came from the world of video games. Powerful graphics processing units, or GPUs, turned out to be the perfect engine for training these super complex models.
Okay, so the main goal here with deep learning is to copy how we learn. So it only makes sense that we start with the brain's most basic building block, the neuron. In the deep learning world, the artificial version of a neuron is called a perceptron. It's a really simple idea. It takes in some information, does a quick calculation, and then produces an output. You can just think of it as a tiny little decision maker. Let's make this real with an example. Say we want to predict if a student is going to pass an exam. We could feed a perceptron some simple inputs: how many hours they studied, how many hours they played, and how many hours they slept. And based on that, it has to make a simple prediction: pass, which we'll call a 1, or fail, a 0.
But how does it learn to make the right prediction?
Well, it's actually just like teaching a child. A newborn has no idea what a mobile phone is. You have to show it to them over and over and over. As developer Krish Nayak says, it can take months of training just for a baby to say, "Papa." You're literally training an original human neural network.
A machine's neural network learns in a very similar way, through a constant, relentless process of trial and error. So let's break down what that learning process actually looks like under the hood.
The entire learning process boils down to this really cool four-step loop. First, the network makes a guess. This is called forward propagation. Second, it measures how wrong that guess was. It compares its answer to the real answer, and this calculation of wrongness is done by a loss function. Third, and this is the magic part, it travels backward through the network and adjusts its internal connections just a tiny bit to try and reduce that error. This is called backpropagation. And finally, it just repeats this whole loop thousands, often millions of times, getting a little bit smarter with every single pass.
So what is the network actually adjusting during backpropagation? It's adjusting what are called weights. You can think of these as millions of tiny little adjustment dials between all the neurons. The entire learning process is just figuring out which dials to turn up or down to get closer to the right answer. That's all backpropagation really is, an automatic dial tuner.
And finally,
Each neuron has this thing called an activation function. The best way to think of it is like a bouncer at a club. It looks at the information coming in and decides if it's important enough to be let through to the next layer of neurons. This simple on-off switch is what lets the network learn incredibly complex patterns, not just basic ones.
So there you have it. This simple process, making a guess, measuring the error, and tuning the dials, when it's repeated at a massive scale across millions of data points, well, that's what's powering the entire modern AI revolution. So let's just quickly recap the key takeaways. Deep learning is a special field of AI that really exploded because of two things: big data and powerful GPUs. Its whole idea is to mimic the brain's neurons, and it learns through a constant cycle of trial, error, and correction. And that brings us to a final, pretty powerful thought. This entire world-changing technology is built on a simple idea we all understand: learning from your mistakes. So if machines can now learn from experience, much like we do, the only real question left is, what are the limits?